like the sum. Multiply? Product means multiply. So I want to multiply to 0. So what times what is 0?
0, 0.
Yeah, 0 times 0 is 0. What else can I multiply to get 0? Anything times anything is 0?
No, anything times 0 is 0.
Anything times 0. So like 10 times 0 is 0. So it doesn't matter what I take. We're going to use an x, a variable, is 0. And there's also one other one. How else can I multiply to get 0? 0 times, yeah, anything. I'll change it to y this time just for funsies. You could do x again if you want. So either the first part has 0, 0 times something is 0, or something times 0 is 0. Or both parts are 0. 0 times 0 is 0. Okay, I'm going to be using highlighters for this first part if you didn't pull that together yet. I'm going to use yellow and blue. You can use whatever colors. Alright, so the 0 product is if two parts multiply to 0, I'm going to say to equal 0, but you could just write 2, 0, that's fine. If two parts multiply to equal 0, to be 0, or at least one of the parts equals 0. And I'm spelling 0 out because otherwise sometimes mine look like O's. I don't know. Helps me when I look back at my notes to write out 0. So we're going to be solving. Solving means we want to get the x by itself or the y or whatever the variable is. We have two examples we're going to do today using the 0 product property. The second example we're going to talk about factoring as well. It's going to be a great time. Alright, so example number 1. We're going to be solving an equation, which means we're trying to get that x or that y, or in this case the v by itself. And I have the quantity of v plus 3 times the quantity of 8v minus 1 equals 0. You're about 5 lines down if you just want to start on the example and leave about 4 lines for the definition. Alright, so we have it equal to 0. Am I multiplying two parts to make 0? Yeah, what's the first part I'm multiplying by? Yeah, v plus 3. So I could make v plus 3 equal to 0. And I'm going to solve that. How would I get rid of, oh, and then if you want to highlight it again, you can, just for funsies. It's fun to highlight. I like highlighting. Alright, how do I get rid of a plus 3? Minus 3. Minus 3. So v would equal 0 minus 3 is negative 3. So let's check that. Does that make sense? Negative 3 plus 3 is what? Negative 3 plus is 0. Does it even matter what 8 times negative 3 minus 1 is? Because whatever that is, I'm going to get 0 times that, and my answer would be 0. So that works for the first part. Either this first part could be 0, but there's another answer. What else could be 0? Yeah, the second part. Because I could have something times 0 equals 0. Just one of these has to be 0. This negative 3 makes it so that this first part is 0. But now we could have something times 0. So I have to figure out when would this be 0. So I'm going to write 8v minus 1 equals 0. And again, if you just want to highlight it one extra time, just for funsies. All right, and we're going to solve. This one's a two-step equation, so I have to decide if are we going to get rid of the 8 first or get rid of the 1. The 1. So how would I undo a minus 1? Plus 1. We do it to one side. So we get 8v equals 0 plus 1 is 1. And then we have to undo this multiplying by 8. So we divide by 8. Good. Again, if we do it on one side. Can we do 1 divided by 8? No, we get a decimal. But we're going to leave it, instead of a decimal today, we're going to just work with fractions. Whoops. So if I just do 1 divided by 8 on decimals, if you're not sure, you can always hit that circle with the 2 squares. And it's just going to stay 1/8. So 1 over 8. So this equation has 2 real solutions. Remember we had those 3 options. It can either have 2 real solutions. What's our other options? 1 solution or no real solution. So this one has 2 real solutions. We have 2 numbers. I'm just going to write it nice for my answer. V equals -3 or V equals 1/8. Those are my 2 answers. Now you guys are probably like, well, this is fine and dandy. Love it. It's amazing. But what the heck does this have to do with this unit? Because this unit is all about solving quadratics. And what are quadratics again? Yeah, that 8x squared plus bx plus c. Is that what that looked like? Ax squared plus bx plus c? No. So guess what we get to do next? It's going to be so good. All right, number 2. We're going to solve 3x squared minus 10x minus 25 equals 0. So does that look like number 1 where we have 2 parts we're multiplying to equal 0? No. Could I draw a line down the equal sign and start solving? If I did, I'd end up with this x squared and x. Can I combine those? No. So that's the whole point of this unit, is we have to figure out ways to do this. One way to do it is we could graph this equation and see where it crosses that y at, or where it crosses at 0. The problem is this time we get a fraction or a decimal, and that's going to be really hard to find on a graph. So our other way of doing it is by taking this here and trying to write it as 2 binomials. So this is our flashback to Unit G. Those of you that maybe are thinking Unit G already, yep, you got it. We're going to factor. All right, so first part of factoring is identifying our A, B, and our C. This is where I'm going to use my colored pencils. What is our A? A is 3. What is my B? B is, oh, I'm using blue. I thought it was purple. Sad. B is -10. And what is my C? C is -25. All right. Who remembers to start factoring? What are we going to start by multiplying first? A times C. We're going to do A times C. All right, and what is our A? 3 times what is our C? -25. What? Oh. 1 second. What's 3 times negative 25? Negative 75. Awesome. So we do A times C to get that number. But then we want to think our two equation. One equation is adding, and one equation, I'm sorry, I just screwed it up. My bad. Adding. And we want it to add up to what part of our original equation? Yeah, our B, which is negative 10. Where are we going to find those numbers that we can figure out multiply to negative 75, but add up to negative 10? Blue sheet! Amazing! Those of you that have your blue sheet, grab that thing out. If you don't have your blue sheet, you're in luck. I have still like 100 extra. Who needs a blue sheet? You get a blue sheet. You get a blue sheet. You need a blue sheet? Sure.
I'm trying to try out right now.
I think so. That's okay. I lost mine too, so. Oh, whoa, you guys all got your blue sheet?
Yeah.
Amazing. Lauren, do you have your blue sheet?
I already had it out and I knew it was
Oh,
fine.
perfect. Makes sense. No, I know you like it. Beautiful. Need one? Need one? Need one, Candace? Alright, so on your blue sheet, can you guys run this one too? Thanks. Are you going to look at the box of 75 or the box of 10?
75.
Good, 75. So we're looking at this box. There are 3 pairs in it. We need to decide which one of those pairs can I add or subtract to negative 10. So 5? What about 75 minus 1?
No.
Okay. Well, 75 minus, maybe. That's 74. 3 plus 25 is 10?
No.
25 minus 3?
No.
5 plus 15?
Yes.
But we're going to subtract. Which way do we want to subtract? If I have 5 and 15,
You want 15 and then
to be the negative, the 5, or the 15 to make a negative 10?
5.
I want my answer to be negative. So if I want a negative answer, do I want more positives or more negatives? More negatives. So my bigger number has to be negative. Whoa, we're not even done yet. Lucy's being weird over there, talking to herself. What? Alright. Well, don't believe Taylor. Alright, now what's our next step after that? The square thing. Also known as the area model. Alright, in our area model, what am I going to put in that first box?
3.
Our A, so our 3x squared. What's going to go in our last box? C of 25.
And then we got
Okay, and then we want the B to be split between the 2. And the B has an X, so both of these will get an X. But instead of using negative 10, we wanted to split that up, and we found the 2 numbers that make negative 10.
negative 15.
Negative 15 and 5. Which one do we want on top?
Negative 15.
You want negative 15 up here? Okay, negative 15 and 5.
And then we just got
Yep. Now that we have the insides, we then need to find outsides. So on your blue sheet, we can look at 3 and 5. What is the biggest number that both 3 and 5 have? 1. So I'm going to take out a 1. Okay, give me 1 second. Alright, and then they both have an X. Okay, and then we can keep factoring if that's your preferred method. I could look at 15 and 25. 15, 25. What's the biggest number that 15 and 25 both have? 5. But what else will I want to factor out of this one? Negative, because they're both negative. So negative 5. Do they both have an X? Nope. Okay. Then I could do 3 and 15. What's the biggest number in both 3 and 15? 3. And they both have an x. And what's the biggest number for 5 and 25? Thank you, Sonia. 5. Another way you could have done that is once you got one of them, you could think to multiply to get those other inside ones. Alright, how are we doing? Making sense? We're going to write our We're going to write our binomials. So what's going to go in our first binomial? Good, this 3x plus 5 goes in one of them. What's going to go in the other one? 1x and x. No, I can just write x minus 5. These go together. Alright, now, last unit, that was it. That's where we stopped. There was an extra step today. When you looked at the original problem, what was the extra thing that was in that original problem? It has to equal 0. So this is what that equals. It equals 0. Alright, on your quick check today, this problem gets really long, so this will all be there for you to fill out. And then this next step you'll have to do like on a whiteboard, and then you just get your answer and you'll have to fix it. Thanks. Alright, so when it equals 0, either the first thing equals 0, and it's 0 times something is 0, or the second thing equals 0. That's our zero product property. That's what we're adding on today. So I'm going to split this into two equations. Okay, and again, on your quick check, this part won't be actually shown on your quick check. You'll have to do this on a whiteboard. So 3x plus 5 equals 0. That's our first option. And our second option is x minus 5 equals 0. Now, some people, they want to jump through really quick, and they want to be like, oh, that's negative 5, and that's 5. No way, Jose. Okay, we have to solve it. So on this one, my blue one, 3x plus 5, how would we get rid of that? What would we get rid of first? The 3, and do it adding 5. Do it to one side. We do it to the other side. So 3x equals 0 plus 5. What's 0 minus 5, people? Negative 5. 3. And can we do negative 5 divided by 3? No. So we just get x equals, we just write it as a fraction, negative 5 over 3, which stands for 5 divided by 3. Fancy. Alright, then this other one should be really quick. Minus 5. Yep, add 5. So x equals 5. So if you want to write your answer really nicely so that they're together, we'd get x equals negative 5/3 or x equals 5. Alright, I know I told you today was like us adding on one more step to what we've already done. Tomorrow we're going to add one more step onto this. Just a little one. Just a small one. Very small step. It's almost the exact same. When we do it tomorrow, you guys will be like, what's the difference? You guys will have a tough time even remembering what the difference is. So we're going to have some time to practice with this factoring, which is good news, bad news. Good news, if you didn't do good in these stuff, this is your time to relearn factoring in case you want to retake your Unit G test. Alright, I would really highly recommend everyone doing their quick check today.